Here's one last spherical coordinates integration question, just with one new twist here. Integrate f of x, y, z is, okay, we can see that's going to be rho here, over the region x squared plus y squared plus z squared is less than or equal to 2z. Okay, so we know we're looking for bounds here on theta, phi, and rho. So let me point out, there's a lot going on here. So the first thing that we will probably do is say, okay, rho squared is less than or equal to 2 times z. Remember, z from our chart is rho cosine phi. And let's see here. If we divide by rho won't be negative. We can divide both sides by rho. This will give us rho is less than or equal to 2 cosine phi. So we have a nice upper bound here that we're going to have here on rho. Also, something that we should just know is, of course, this will never be negative here. So our bounds on rho look like they're going to be 0 to 2 cosine phi. No, there's no specific things about x's and y's. There's no constraints specifically about x's and y's. So we're going to do one full loop around the circle. Theta runs from 0 to 2 pi. What about phi? So here's maybe the interesting thing about phi that we have to catch, is that if we just look at this, it looks like it's telling us, rho is less than or equal to 2 cosine phi, but this also gives us a bound on phi. Because we know x squared plus y squared plus z squared, that's never negative. This whole thing is greater than or equal to 0. This shows right here, combining this part and this part together, shows 0 is less than or equal to 2 times z. When is z, here's the z-axis. Z is positive all the way from this is 0, this is phi is equal to 0, to this is phi is equal to pi over 2 here. So this gives us, it's not all the way from 0 to pi, common mistake to make here. This is phi is from 0 to pi over 2. We can also see that from those lines right there. 0 is less than or equal to 2 cosine phi. Cosine phi is non-negative exactly in this interval here. Okay, so we are ready to write down our triple integral. Theta runs from 0 to 2 pi. Phi runs from 0 to pi over 2. Rho runs from 0 to 2 cosine phi. Our integrand is rho times our standard rho squared sine phi d rho d phi d theta. The theta stuff can get factored out here. Okay, and let's see. Rho times rho squared is rho cubed. Great, so rho to 4th over 4. Plug in rho from 0 to cosine phi. Phi. Okay, this is 2 pi. And then this will give us, when rho is 2 cosine phi, this will give us 2 to the 4th is 16 over 4 is 4. Sine phi, cosine phi to the 4th d phi. And it looks like, just as in the previous problem, we do a substitution here. We substitute in u is equal to cosine phi, du is equal to negative sine phi d phi. So negative du is equal to sine phi d phi. Okay, what are our new bounds here? When phi is 0, cosine 0 is 1. When phi is pi over 2, u is cosine pi over 2 is 0. So 2 pi times -4, u to the 4th goes to u to the 5th over 5. Plug in u from 0 to 1, 8 pi over 5. And that is the correct answer. I do know that off the top of my head. Okay, so once again, tedious calculations here. Don't lose sight. Coming up with the bounds is the most important thing for you to get from this problem.